Now we can make prediction using a classifier. But how do we know if the model is making correct prediction? We can evaluate its performance. For measuring model performance in classification, accuracy is a commonly used metric. Accuracy is the number of predictions divided by the total number of observation. Measuring model performance. How do we measure accuracy? We could compute accuracy on the data used to fit classifier. We could compute accuracy on the data used to fit the classifier. However, as this data was used to train the model, performance will not be indicative of how well it can generalize to unseen data, which is what we are interested in. So, compute accuracy. It is common to split data into a trained set and test set. We fit the classifier using the train set. Then we calculate the model's accuracy against the test set's labels. So, first to do that programmatically, we import the train test split from Scikit-Learn-Model class selection. We will call train test split passing our feature and targets. Commonly use 20 to 30% of our data as the test set. By setting the test size augment to 0.3, we use 30% here. The random state argument sets a seed for a random number generator that splits the data. Using the same number when repeating this step allows us to reproduce the exact split and our downstream results. It is best practice to ensure our split reflects the proportion of labels in our data. So, if our churn occurrences in 10% of observation, we want 10% of labels in our training and test to represent churn. We can achieve this by setting satisfy equal to y. So what is this? I'm repeating again. Stratify is y. Why we did that? Churn accuracy in 10% of observations. We want 10% of labels in our training and test sets to represent churn. We achieve this by setting stratify equals to y. Train test split returns 4 arrays: the train data and the test data, train labels and test labels. We unpack this into x underscore train, x underscore train, x underscore test, y underscore train, y underscore test, respectively. We then initiate a KNN neighbors KNN model and fit it to the train data using the dot fit method to check the accuracy. We use the dot score method passing x underscore test, y underscore test. The accuracy of our model is here 88%, which is low given our labels have a 9 to 1 ratio. So next, model complexity. Let's discuss how to interpret K. Recall that we discussed decision boundaries, which are thresholds of determining what label a model assigned to an observation. In this image shown, as K increases, the decision boundary is less affected by individual observations, reflecting a simpler model. Simpler models are less able to detect relationships in the datasets, which is known as underfitting. In contrast, complex models can be sensitive to noise in the training data rather than reflecting the general trend. This is known as the overfitting. So here we can use the interpret K using a model complexity curve with KNN model. We can calculate accuracy on the training and test sets using incremental K value and plot the results. We create the empty dictionary to store our train and test accuracy and an array containing a range of K values. We use a for loop to repeat our previous workflow, building several models using a different number of neighbors. We loop through our neighbors array, and inside the loop, we initiate a KNN model with n underscore neighbors equal to the neighbor iterator and fit to the training data. We then calculate training and test accuracy, storing the result in their respective dictionaries. Then we plotting our results after our for loop. We then plot the training and test test values, including a legend and labels. Model complexity curve. Here the result as K increases 15, we can underfitting where performance plots on both test and train sets as indicates in this plot. Here the peak test accuracy actual occurrences at around 13 neighbors. Yeah, let's practice. So I'm moving to my Jupyter notebook here. Jupyter notebook. This is my Jupyter notebook where I need to find my accuracy. So in order to do that, first I need to import these statements. So as I said, we need to import the train test split. Then as my X values, this is my X. And these my Y values. I need to split. This is my and fit, KNN fit. I'm using the KNN fit. And this is the score. It is 85%. It's very less. So we will see when K increases. We're taking neighbors as 1 to 13. We're taking two variables, dictionary variables, and I'm writing the for loop. So here the for loop. So these many values are came. Now we are going to plot these values. So how to plot? Just I'm plotting. To plot, we need to import the matplotlib. So what I will do, I will copy paste it here, and I will use the matplot. Okay, I will use the matplotlib. I'll use the this particular. I need to import the this what is called matplotlib. To import that, first I need to write this command. I need to import this thing. After importing, I need to use this plot. So if you see this, the how the this one at the 8 it is where the things will be looks like this. So when the here see this training accuracy decreases and test accuracy increases as the number of neighbors gets large for the test set, and accuracy peaks 7 neighbors. When the neighbors are 7, suggest it's optimal values for the model. So this n is 7, that is where the accuracy. Yeah, when the when is when k n underscore neighbors is 7, the plot is stable. This is the way to find the accuracy of a model. Thank you.